evening, pre-algebra. Mr. Lawrence here with your flipped lesson for Tuesday. What is today? March 27th, I think. Jeez, I wish it was Friday. I know you guys do too. Don't worry, it'll be here soon enough, guys. We can make it through. A few more days and we are on break, all right? So let's get some hard work. We got a test on Friday over transformations, rotations, reflections, dilations, translations, and I have a mental blank, scale factors, right? Okay, now yesterday we reviewed, let me see if I've got them on here. I think I have the notes right here handy. We reviewed, this was a translation where we just slid it down 2 and right 3. And remember, you have to specify. You can't just say, oh, it's a translation. You have to tell how it moved. And that's one acceptable way, down 2 over 3. Another way could be as simple as saying down 2, right 3. And you can't really just say over 3. You got to say right, because you got to tell if it's positive or negative. Okay. All right. So, and then a reflection across the y-axis was the blue one. All right. The black one to the blue one. You can see the mirror is the blue dotted line. The green one is a reflection across the line y equals 1. Remember, we listed our points. I know Jocelyn was getting really good at that on Monday after school. Very proud of her for that. Okay. Hopefully she'll share some of that with her friends who might be having a little trouble. And then the red one was a reflection across the line x equals -2. And there we listed the points again and counted the spaces to the mirror. Okay. And then we did a 90 degrees counterclockwise rotation. Remember, the clockwise and counterclockwise rotations, I do the same exact way. And I get my signs, you know, I flip x and y, but I get my signs based on what quadrant I'm going to end up in. So you just got to remember, look up at the clock. The red hand is moving clockwise, all right? Other way is counterclockwise, means against, okay? All right, so now we have to talk about dilations, and we know 2 types of dilations, okay? The first type of dilation that was with a point at the center. Like, for example, I'm going to make B at the center. And I'm going to do a dilation of 3. All right? All right? Meaning I want to use a scale factor of 3. Sorry, I shouldn't say dilation of 3. I should say scale factor of 3. Scale factor is 3. So right now, segment AB is 2 units long, right? Well, it's going to have to become 6 units long because my scale factor is 3. I'm going to blow it up 3 times. So the new A prime would go here. All right. So the new side is 6. The old side was 2 units, and the new side of the square is 6 units long. Now, similarly on BC, it's 2 units long. I'll multiply by 3, and it'll go up to 6, and there's C prime. Okay, and it's 6, and it was 2. Now, by the way, I'm almost done drawing my my dilated square, but let's check this out. The area of the little square is 4 square units, right? Okay, in a minute we're going to find the area of the larger square, the dilated one. So that'll take D prime here because it can't lose its shape. And there we go. We just dilated with B at the center. Notice I circled B. B's not going to move. Okay, now, what would the area of the big one be? It would be 36 units squared. Now, some of you are thinking, well, wait a minute, Mr. Lawrence, if the scale factor was 3, it should have been 12. No, because normally to do area, we do length times width. But in this one, we're doing area, and we have triple the length times triple the width. Right? We tripled the length and width. Would you agree with that? And now, because multiplication is commutative, I can rewrite this second one as 3 times L times W, or more simply 9LW. And look at that. That is 9 times larger than that one. Okay? All right. Good deal. I am going to erase some of this. Hold on one second. Okay, I've got the screen clear, and now I'm going to do the second type of dilation, the second type that we learned about. All right, the second type of dilation, and that is with the origin at the center. The center is at the origin, right? Not at 0, at 0, 0. You got to give 2 coordinates, right, for the point, 0, 0. All right, and dilation could mean to shrink, so I'm going to do it 2 ways. First, I'm going to do it with a scale factor of 3, and you'll see how it'll change, okay? Now this one, I need to know the original coordinates. See, I think these are easier. There's less thought involved in them. It's just more a mechanical process. So I write down the coordinates, 3, 3, and then D would be at 1, 3. Okay, my scale factor is 3, so all I do is multiply each coordinate by 3. So A prime goes right here. B prime goes to 9, 3. Right, just like that. C prime goes to 9, 9. Should be right about there, I think. And D prime goes to 3, 1. No, 3, 9, excuse me. All right, so 3 and then 9 would be right there. And there's D prime. And notice I have a perfect square. Okay. And it should be 6 by 6 on a side. And its area should be 9 times greater. Let me just see something here. Are these all connected? Let me connect all these and try something here. I think this is going to work out cool. Okay, let me group them together. And I'm going to clone this infinitely. Yeah, look at this. Let's see. There's 1, 2, 3, 4, 5, 6, 7, 8, and 9. You see, there are 9 of them. 9 of those little squares fit into that big square. Square ABCD. 9 of square ABCD fits into square A prime, B prime, C prime, D prime. And that's because we tripled the length and we tripled the width. Okay, now this time I'm going to do a scale factor of, say, 1/2. Okay. And pointing out, A moved. So I'm going to do a scale factor this time, 1/2. The origin is still the center. All right, so I'm going to call A double prime. I'm going to multiply each by 1/2. Well, I'm not going to get bent out of shape. 1 times 1/2 is 1/2. So 1/2, 1/2 would be there. So that'll be A double prime. I don't think I'm in my fine marker. There we go. All right, B double prime. Well, 1/2 of 3 is 1 1/2. And 1/2 of 1 is 1/2. So I'm going to go to 1 1/2, 1/2, right about there. B double prime, connect those. C double prime, well, this is going to be 1 1/2, 1 1/2, because they're both 3. And so 1 1/2, 1 1/2 be right about there. C double prime. Okay. And D double prime will be at 1/2 and 1 1/2. Okay. And there's D double prime. And there we go. Now, in this case, the length was changed by 1/2, and the width was changed by 1/2. So my area changed by 1/4. 1/4. What I'm saying is that this little blue guy, A double prime, B double prime, C double prime, D double prime, 4 of them would fit inside the black square. They would go here, here, and here. Okay, 1. Maybe I should do that in a highlighted color so that it shows up better. Okay, hold on. There we go. And let me just take a little highlighter. There's 1, 2, 3, and 4. See? It's 1/4 of the area. Okay, very good. That's the lesson for today. Remember, there's a test on Friday. I will keep posting videos Wednesday and Thursday to help you review. Mr. Lawrence signing off. Good night, everybody.